Hello everyone, we're from 12B Group 2. Today we're going to discuss about the mechanics past paper with the code 970942 Winter 2022. But first, let us introduce ourselves starting from Vania.
Konnichiwa, watashi wa Fanya desu. Yoroshiku onegai shimasu.
Then we have Farel.
안녕하세요 여러분. 제 이름 팔렐리에요.
And there's me. 大家好，你们朋友，我叫
Okay, now we're going to start with number 1. A cyclist is riding a bicycle along a straight horizontal road AB of length 50 meters. The cyclist starts from rest at A and reaches a speed of 6 at B. The cyclist produces a constant driving force of magnitude 100 Newton. There is a resistance force, and the work done against the resistance force from A to B is 3,560 joules. Find the total mass of the cyclist and the bicycle. For this question, we can use the formula of work and energy conservation, which is work done by driving force minus work done by resistance equals to change in potential energy plus change in kinetic energy. Now we can write down the whole formula for each. Fd equals to potential energy is mgh plus half mv square minus u square. Now we can input the values. The driving force magnitude is 150 meters minus 3,560. And then the change in potential energy is 0 because it is a straight horizontal road. And then half m v squared is 6. And then we calculate, going to be 3,560 equals to 18 meters, 18 m, which is going to be 80 kilograms. The next one, we have question 2. A particle P of mass 0.4 kilogram is in limiting equilibrium on a plane inclined at 30 degrees to the bodoh, lupa gua. So next one, we have number 2. A particle P of mass 0.4 kilogram is in limiting equilibrium on a plane inclined at 30 degrees to the horizontal. Show that coefficient of friction between the particle and the plane is 1 over 3 square root of 3. First of all, to make it easier, we can draw a diagram. Here is the particle of mass. The weight is 0.4 times 10, so it's going to be 4 Newton. For the x component, we have 4 sine 30. And then for the y component, which is the same as the normal force, is 4 cos 30. Sigma fx is going to be 0, and then fx minus the friction force equals to 0. Then we can input directly for sine 30 minus mu for cos 30, which is n. For sine 30 is going to be 2, and then for cos 30 is going to be 2 square root of 3 mu. Now the coefficient is going to be 1 over 3 square root of 3. The force of magnitude 7.2 Newton is now applied to P directly up a line of greatest slope up of the plane. Given that P starts from rest, find the time that it takes for P to move 1 meter up the plane. Now we can copy the diagram from the previous one. We also have 7.2 Newton here. For the sigma, Fx component is equals to ma. Dx minus Fx minus Ff equals to ma. F dx is 0.2 minus f of x is 4 sine 30 minus 1 over 3 square root of 3 and then 4 cos 30. And the mass is 0.48. 0.2. 4 sine 30 is 2. 1 over 3 square root of 3 times 4 cos 30 is 2. This is going to be 3.2 equals to 0.48. Now A is going to be 8 meter per second square. Next we use the kinematics formula, which is S equals to UT plus half AT square. S is 1 meter, and then since it starts from rest, U is 0, half AT square. So now 1 is equal to 4t square. So t is equals to 0.5 second. Okay, now we're moving on to number 3. A particle of mass 0.3 kilogram is held at rest by 2 light inextensible strings. One string is attached at an angle of 60 degrees to a horizontal ceiling. The other string is attached at an angle alpha to a vertical wall. The tension in the string attached to the ceiling is 4 Newton. Find the tension in the string which is attached to the wall and find the value of A. So now to make it easier, we can draw a small diagram here. This is the Y and this one is X. For X, this is the positive region, this is negative, and for Y, this is the positive, and down here is the negative. And here is for N. For the X component, it is going to be T sine alpha, which is going here, and negative 4 cos 60. It's a negative because it's going to this direction. Going to be 0. T sine alpha is going to be the value of 4 cos 60 is 2. And for the Y component, it's going to be for sine 60 positive because it's going here. And then for this one, it's going to be negative because it's going here. Also, since there's a mass, there's going to be a weight. Mg equals to 0.3 times 10 equals to 3 Newton. So minus 3 as well. So negative 3. The value of 4 sine 60 is going to be 2 square root of 3. And then t cos alpha. Since there's a sine and cos, we can use tan alpha equals to sine alpha divided by cos alpha. And then we can input directly 2 over negative 3 plus 2 square root of 3, which is equal to 76.9 degrees. And now for the tension, we can input into each one of these equation, either this or this one. T sine alpha minus 4 cos 60 equals to 0. So T sine alpha is equals to 4 cos 60. As we know, alpha now is 76.9 degree equals to 4 cos 60 is 2. So the value of T is 2.05 Newton.
So now we're going to go over question number 4. A car of mass 1,200 kg is traveling along a straight horizontal road AB. There is a constant resistance force of magnitude 500 Newton. When the car passes point A, it has a speed of 15 meter per second and an acceleration of 0.8 meter per second squared. Okay, first let's underline all the numerical values, the mass of the car, and then the resistive force, the speed of the car when it passes point A, and then its acceleration. Question A, find the power of the car's engines at the point A. So for this one, we are going to use the formula to find the power. We're going to use the formula P is equals to Fd times V. Fd is our driving force, but since we were not given a driving force, we first need to find our driving force. We'll be using the formula sigma F is equals to Ma. Sigma F is the total amount of mass, so it's Fd, the driving force, minus the Fr, our resistive force. We have our Fr value, which is 500 Newton, and then we also have our mass and acceleration at point A, which is 1,200 times, that doesn't look like a zero, sorry, times 0.8. Let's put that in the calculator first. Okay, now since our driving force has been found, we can use the formula to find the power, which is P is equals to Fd times V. We were also given our V, which was 15 meter per second. Okay, so that's the answer for question A. Okay, now we're going to do the B part of this question. The car continues to work with this power as it travels from A to B. The car takes about 53 seconds to travel from A to B, and the speed of the car at B is 32 meters per second. First, we're going to underline the numerical values. We have 53 seconds, the time taken for the car to travel from A to B, and then the speed of the car at B, which is 32 meters per second. And question B asks us to show that the distance AB is 1,362.96 meters. Okay. In this question, it also states the car continues to work with this power, which means that this power is the power that we searched for in question A, the 21,900 watt for the power. So since we are given a power time, we're also given the speed of the car at B. We'll be using the work and energy conservation formula, which is work done by driving force minus work done by a resistive force is equals to change in potential energy plus change in kinetic energy. There are few formulas for finding energy, which is work done. The common one that many people use is Fd times d, but since we don't have the distance right now and we need to find the work done and by driving force, we can use our power times by a time, this formula. Power is equals to energy over T. Energy is the same as work done, and so we can use this formula. So P times T is equals to the work done. So we'll be using the 21,900 times 53 seconds for work done and by driving force, minus 500 D. The D is the distance that we're going to be finding, which is this one. And 500 comes from question A. Resistance, force, magnitude is 500. And our delta change in potential energy is 0. Why is it 0? It's 0 because there's no change in the height. like what it's stated in question A, a car of mass 1,200 kg is traveling along a straight horizontal road. A straight horizontal road means that there is no incline at all from the road, so there is no change in our potential energy. Plus half mv square. But no, plus half mv square minus u square. Our m is 1,200 or 1,200, and then our v square is the 32 meter per second, which is currently at b, the speed at b, minus 15 square, which was the speed at a. Now we'll do our calculations. Now you can just use a normal math formula. You just change the sides. This goes here and this goes here. You know the basics math.
Next, we will be doing number 5. A block A of mass 80 kilograms is connected by a light and extensible rope to a block B of mass 40 kilograms. The rope joining the two blocks is taut and is parallel to the line of greatest slope of a plane, which is inclined at an angle of 20 degrees to the horizontal. A force of magnitude 500 newtons inclined at an angle of 15 degrees above the same line of greatest slope acts on A. The blocks move up the plane and there is a resistance force of 50 newtons on B, but no resistance force on A. Find the acceleration of the blocks and the tension on the rope. So first we have to draw on the diagram every force that is given to us, which is first the resistive force of 50 newtons on B. It could be friction or air. Next we draw the weight of each of these blocks, with B being 400 newtons and A being 800 newtons. There's also tension in between these, which is unknown for now. Now for the force upwards on A, that is 500 times cos 15. Now since the blocks are moving up the plane, the forces that are positive will be the ones moving up, which is for A, 500 cos 15, and for B, the tension. So first we will be doing A, which is using the formula of summation F, or sigma F, sigma of force is equal to mass times acceleration. So A is 500 cos 15 minus 800 sine 20 minus tension is equals to 80 times acceleration. And for B, it will be tension, since it's the one going up, minus 400 sine 20 minus 50, which is equal to 40. Now we can add these up. This will be 120A, and the tension will cancel each other out, because this one's negative, this one's positive, and this will equate to this will equate to 22.54. And so acceleration will be 22.54 divided by 120, which is 0.188 meters per second square. That is the acceleration. Next, we can use one of these formulas that we've already made to find tension. I will be using the second formula because it has less trigonometry. T is minus 400 sine 20 minus 50 is equal to 40 times 0.188 from acceleration. So T will be equal to, we just add everything up, which is which brings us to 194.33 newtons. And that is for 5A. Next is 5B. Find the time that it takes for the blocks to reach a speed of 1.2 meters per second from rest. So we will be using a Suvat equation. V is equal to U plus AT. Since we now know the acceleration, we can use this formula to reach a speed of 1.2 from rest, which means the U is equal to 0. So V is 1.2 equal to 0 plus 0.188 T, which makes it into 1.2 divided by 0.188 equals T. And this becomes T is equal to 6.383, which is 6.3 seconds. Number 5 is done.
Okay, now we're going to go over question 6. Three particles A, B, and C of masses 0.3 kg, 0.4 kg, and mkg respectively lie at rest in a straight line on a smooth horizontal plane. The distance between B and C is 2.1 meters. A is projected directly towards B with a speed 2 meters per second. After A collides with B, the speed of A is reduced to 0.6 meters per second, still moving in the same direction. Question A asks us to show that the speed of B after the collision is 1.05 meters per second. So first, let's draw a diagram. That's not a very good circle, a particle. This is A, and this is B, 0.3 kg, and then 0.4 kg. Its UA is 2 meters per second, and then this UB is 0. For this one, we don't have to underline the numerical values because most of these values are just mass and just in speed. For collision or momentum, that's usually the only values that you really use, since the formula is just MAUA plus MBUB is equals to MAVA plus MBVB. So in this one, you don't really have to underline and the numerical values. And then after the collision, as I stated previously, the formula we're going to be using is the momentum formula, which is MA is equals to UA plus MB times UB is equals to MAVA plus MBVB. We'll just put the values in. I'll make this smaller to save some space. Okay, we found the VB, and it is shown that it's 1.05 meter per second, and for the velocity of B. Now we're going to move on to question B. After the collision between A and B, B moves directly towards C. Particle B now collides with C. After this collision, the two particles coalesce and have a combined speed of 0.5 meter per second. In question B, I've already drawn the diagram. Oh wait, I forgot. In question A, it also states that there is a distance of 2.1 meter. 2.1 meters. There. But it's not really important for question B. It's going to be important for question C later on. But it's just a small detail that can be added. Okay. So for this, I have drawn the diagram for B and C, particle B and C. B has a mass of 0.4, and then its initial velocity becomes its previous velocity from A becomes its initial velocity, of course, since there is a collision between B and C. Therefore, there will be there will be a final velocity from that collision. So our previous velocity becomes our initial velocity. So UB is 1.05 meter per second, and C is at rest, so 0. And in question B, ask for find the mass of particle C. Particle B collides with particle C and coalesce. So it means their velocity will be the same as they have become one, like this. Not become one, coalesce. So the formula that we'll be using is MBUB plus MCUC is equals to, open bracket, MB plus MC times V. So MBUB is 0.4 times 1.05 plus 0 since it's at rest. And then MB is 0.4 plus MC times 0.5. You can just change the positions of the numerical values. So 0.4 times 1.05 divided by 0.5 is equals to 0.4 plus C, which is 0.84, and then 0.4 plus MC. So MC is equals to 0.44 kg. That's the answer for part B of question 6. Okay, now we're going to go over question 6C. Find the time that it takes from the instant when B and C collide until A collides with the combined particle. Okay, this is a very tricky question, so that's why I've drawn most of the I did all the things that's needed and drawn diagrams. I'm just going to explain it as best as I can. Okay, first is this. I drew the diagram for after the collision with B. So this is after A, after question A. Since the particle A, when it hit particle B, its velocity becomes 0.6, and then velocity of particle B is 1.05. It's also stated that before there is a distance of B and C. There's a distance between particle B and particle C of 2.1. So we first we find the time taken of this one from B to C. We use the formula T is equals to distance over velocity. We put it inside and equals to 2 seconds. This is the time taken for B to C, or B to go to C. Yeah. And then, now this is where it's going to get a bit tricky, and I have a hard time explaining it, but please bear with me. Okay, since the time taken for B to move is 2 seconds. 2 seconds, this is, let's use another color. 2 seconds. T equals to 2 seconds to go here, B to C. In that 2 seconds, particle A is still moving as well. So particle A doesn't rest. It was never stated that it rests, so we're not going to assume. If it's not stated that it's rest, so it means that it's still moving, and it still has the velocity 0.6 meter per second. So, by knowing that particle A is still moving, we can find the distance that it has traveled. So we can find this thing. Because since B already moved here, B already moved 2.1 meter to C, of course A is also going to move. So in this one we use the same formula. T times V is equals to S. So 0.6 times 2 is equals to 1.2 meter. For the time B traveled, A also moves. So this is the distance that it's moved. since there's a distance between B and C back at that time 2.1, and A will also move 2 seconds, and it's 1.2. That's why we minus the initial distance of B and C, B to C 2.1 and 1.2 to 0.9. So this is the distance that's left. Distance left. And then now after this is quite hard to explain. We are asked to find the time taken of A when they collide with the other particle. Sorry. When it collides with the combined particle. Okay, so this is A. I forgot to. This is A. This is where A is. And this distance. Wait. This is the 0.9 distance. I forgot to. This is the 0.9 distance from B to C. Okay. So in this case, total distance traveled by the combined particle BC is this SBC. SBC. So we can assume that SBC is not assume. Of course, the formula of finding distance is D equals to velocity times T. That's why we use 0.5 T. This is the substitution. There you go. Substitution of the total distance traveled by BC. But for the distance of particle A, it's it's this big line. Why? Because it's asked from the question, find the time taken that it takes from the instant when B and C collide until A collides with the combined particle. And in the question, none of them has stated that any of these particles will stop moving. So of course these particles are still moving, and that's why we're not going to assume we know that they're moving, but we don't know how much they're moving. That's why we use a substitution and formula. For SBC is this, and for SA, for the distance of particle A, it's 0.6 times T. Yeah, we use the same, but just we use the same substitution formula, just different in their velocity. Now, this is where you would understand why. I think you would understand why. Okay, I wrote due to the particle still moving. So in this diagram, we see what's left of, not what's left, like the distance of particle A to particle BC. Like how much farther does it take for A to collide with BC? It's 0.9, but since particle BC is still moving, that's why you need to add this SBC over here. That's what this SBC is used for. That's why when you're going to add the when you want to use the substitution formula to find the T, this is what you do. So SA, we already have SA, which is 0.6 times T, but let's just write it down first. There's the total time taken. So SA is equals to 0.9 plus SBC. We know why 0.9 is needed, and not 0.1, no. We know why SBC is needed, because SBC is still moving. That's why this small distance, this distance of SBC is still put in that equation. So we just substitute everything inside. We know what SBC is and we know what SA is, so we just put it all in the equation. 0.6T plus 0.9 and plus 0.5T. You move the T to this side, right? And then you get 0.6T minus 0.5. 5T is equals to 0.9, 0.1, and T is equals to 0.9. T is equals to 9 seconds. And that is the total time taken. And for A to collide with the coalesced particles. Thank you.
And finally, now number 7. A particle P travels in a straight line, starting at rest from a point O. The acceleration of P at time t seconds after leaving O is denoted as A meters per second squared, where A is equal to 0.3 t to the power of half for 0 to 4 seconds, and a is equal to negative kt to the power of negative 3 over 2 for above 4 seconds and less than or equal to t, where k and t are constants. Find the velocity of p at t equal to 4. So to find velocity using an equation of acceleration, we usually integrate them. And because the question is asking for t is equal to 4, the first equation satisfies this because of this rule. So first we integrate that. V is equal to a dt. The integration of acceleration in respect to time. And it will be v is equal to 0.3 t to the power of negative half dt. And this will become v is equal to 0.3 times 2 over 3 t to the power of 3 over 2 plus c. Now because it starts from rest at rest from point O, the t and v will be 0, because at rest, it's 0. So it will be 0 equal to 0.2 times 0, 3 over 2 plus c, which makes c equal to 0. And so if t is equal to 4, v is equal to 0.3, 0.2 times 4 to the power of 3 over 2. This makes it so v is equal to 1.6 meters per second. And this satisfies A because it finds the velocity. Next is B. It is given that there is no change in the velocity of p at t equals 4, and that the velocity of p at t equals 16 is 0.3 meters per second. Show that k is equal to 2.6 and find an expression in terms of t for the velocity of p for 4 is less than or equal to t, and less than or equal to capital T. And again, we will be integrating the second equation now because it is greater than 4 and less than t. So v is equal to the integration of negative kt to the power of negative 3 over 2. Let me check again. Yeah. In respect to time. This becomes v is equal to negative kt negative half divided by negative half plus c. V is equal to, well, you can cross out the negatives, is equal to 2 kt negative half plus c. Now at 4 seconds the v is 1.6, so v is equal to 1.6, t is equal to 4, 1.6 equals to 2 k times 4 to the power of negative half plus c. Now 2 times 4 to the power of negative half is just 1, so 1.6 is equal to k plus c. Let's make this smaller so I can have more space. Next, we have to again calculate using the given, which is 0.3 meters per second at 16 seconds. So at 0.3 is equal to k times 16 to the power of negative half. 2 times k times 16 to the power of negative half plus c. And this will become 0.3 is equal to half k plus c. Now with these two equations, which is the 1.6k plus c and 0.3 is equal to half k plus c, we can do subtractions. So 1.6 equal to k plus c is equal to 0.3 equal to half k plus c. Now calculating this, we can do negative 1.3 is equal to half k, and k will be 2.6. Next we have to find the c. So 1.6 is equal to 2.6 plus c. So this makes the c into negative 1. After that, we can put everything back into the equation, which is 2. V is equal to 2 times 2.6 t to the power of negative 1 over 2 minus 1, which is V equal to 5.2 t to the power of negative half minus 1. And that is B complete. Next is 7c. Given that P comes to an instantaneous rest at t is equal to capital T, find the exact value of capital T. So we'll be using the second equation. V is equal to 5.2 t to the power of negative half minus 1. So because it comes to an instantaneous rest, this makes it so the V is equal to 0. 0 is equal to 5.2 t to the power of negative half minus 1. We can play around with this equation, so it makes it 1 equal to 5.2 divided by root of p. We can square these, so this makes it into 1 is equal to 27. Remember, if you square one side, you have to square the other side, but since 1 squared is just 1 as well, I didn't write it down. 27.04, and this will be t. So t, capital T, my bad, it will be 27.04 seconds. Finally, D. Find the total distance traveled between t equals 0 and t equals t, capital T, which is 27.04. So we will be using limits, and because distance is also the integration of velocity, because there's also two parts, we will be using two different equations. The first one being the limit of 0 to 4, which is the 0.2 t to the power of 3 over 2 with respect to time, plus the function of 4 to 27.04 times 5.2 t to the power of negative half minus 1 dt. So integrating this, we will get 0.2 times 2 over 5 t to the power of 5 over 2 with the limits of 0 to 4 plus this will be 5.2 times 2 t to the power of half minus t with the limits of 4 to 27.04. Now, when you substitute 4 into this equation, you will get 2.56. And when you substitute 0, you'll get 0, so skip that. And next, if you substitute 4 into this equation, you will get 2.04. And if you substitute 27.04, you'll get 16.8. Now the total will be 12.8. And this is the final answer, 12.8 meters. That's all. Thank you.